Hello everyone, I am Dr. Munish Bharadwaj from School of Engineering and Technology of IGNOU. So we were discussing about the concrete mix design and some of the methods we discussed in the last lecture, others we will be discussing in this lecture. So in this lecture we will cover the trial and error method, American Concrete Institute mix design method, road node number 4 method, then yield of concrete, and we will also discuss the cement factor. So let us first begin with trial and error method. In this method, the proportion of fine aggregate to coarse aggregate is to find out by trial, which gives the maximum weight of the combined aggregate. The density of particle of fine aggregate and coarse aggregate is nearly the same. The mixture which will give the maximum weight will have the maximum solid matter of, therefore the least voids and surface area. Means we want to have a mix which is having the least voids and the surface area. In another method of trial mix, fine aggregate and coarse aggregate are combined in several proportions. The quantity of cement per unit volume of concrete is found out to give a certain water cement ratio for each mixture. The percentage of sand is known as optimum percentage. The cement requirement will be more for the same consistency. Sand used is more than the optimum because the surface area of the particles will be increasing if we are using the more sand than the optimum value, and in that case we will require more cement. The mix will become harsh for low quantity of sand. Optimum percentage of sand is lower for lower water cement ratio. Now let us see what are the steps to determine the mix proportions of a cement concrete mix. First step is select the water cement ratio corresponding to the design target of average compressive strength of concrete and for the required climatic conditions. So here the two factors are there, the average compressive strength of the concrete and the climatic conditions, and keeping in view the things, we will select the water cement ratio. Then next step is to find out the workability in terms of slump for selected water cement ratio for a particular job. Means we have fixed the water cement ratio, we have selected the water cement ratio, then we have to find out the workability in terms of slump basically for that particular type of work or the job. Now next step is to find out the maximum size of coarse aggregate to be used or which is available. So based on that we will be finding the maximum size of the aggregate. Next step is to mix fine aggregate and coarse aggregate in such a manner that either the mixed aggregate has a grading corresponding to the Flur's formula or mixed aggregate has a fineness modulus as economical value of fineness modulus for combined aggregate, or mix the aggregate so that the weight per liter of the mixed aggregate is the maximum, or the sand corresponds to the optimum percentage. So these are the different criteria. Now next step is to determine the quantity of cement required per unit volume of coarse aggregate to get desired slump by actual trials. Means here we will be determining the amount of cement per unit volume of the coarse aggregate to get the desired slump, and we will be doing it by actual trials. Next step is to find out the actual proportions of cement, fine aggregate, coarse aggregate and water to meet the requirement of strength, workability, durability and economy. So keeping these factors, we will be finding out the actual proportions of the different ingredients of the concrete, and these different ingredients, as you know, are cement, fine aggregate, coarse aggregate and water. Now next method is American Concrete Institute mixed design method. This method is based on the estimated weight of the concrete per unit volume. This method takes into consideration the requirement for consistency, workability, strength and durability. Now let us see what are the steps of ACI mixed design method. First step is, depending upon the degree of workability and placing condition, determine the value of slump. Means first of all we have to find the value of the slump. The next step is, depending on the economical availability and dimensions of the structure, determine the maximum size of aggregate. So after fixing the value of slump, now we will be deciding fixing the maximum size of the aggregate, and that fixing of maximum size of aggregate will take into consideration the economical availability of the aggregate and the dimensions of the structure where the concrete or this aggregate has to be used, because depending upon the dimensions of the structure, the maximum size of the aggregate will change. If it is a narrow element, narrow cross-sectional element, if it is heavily reinforced, then the size of aggregate will be lower. If the size of the structure or the structural element is large, then you can go to the larger size of aggregate. Next step is, for the given slump and the maximum size of coarse aggregate, determine the amount of mixing water, that how much water is to be mixed to prepare the concrete mix. Then next step is, determine the minimum water cement ratio, either from strength consideration or from durability consideration. So either you can use any of this, strength consideration or the durability consideration, and accordingly you will decide the minimum water cement ratio. The next step is to determine the amount of cement per unit volume of concrete from the step 3 and step 4. This cement content should not be less than the cement content required based on durability criteria. So this has to be kept in mind. Determine the amount of coarse aggregate required for a unit volume of concrete. This value is multiplied by the dry rodded unit weight of the aggregate to get the required dry weight. The next step is to determine the amount of fine aggregate. If the weight of concrete per unit volume is assumed, the required weight of fine aggregate is obtained by the difference between the weight of fresh concrete and the total weight of all other ingredients. The weight of fresh concrete may be estimated by using the following equation. Here Wm equal to 10 rho A into 100 minus A plus gamma C into 1 minus rho A upon rho C minus gamma W into rho A minus 1. Let us see what are these different terms, what are these different symbols. Here Wm is the weight of fresh concrete in kg per meter cube. Rho A is the weighted average specific gravity of combined fine and coarse aggregate. Rho C is the specific gravity of cement, that is taken as 3.15. Gamma C is the cement requirement in kg per meter cube, and gamma W is the mixing water requirement in kg per meter cube, and A is air content in percent. So these are the terms or the symbols that are used in the equation. So by using that equation we can calculate that. Now next step is adjust the mixing water quantity on the moisture content in the aggregate. What is the meaning of it? That you know that our coarse aggregate and fine aggregate may be having some moisture, and that moisture which is on the surface of the aggregate, that will be added in the concrete mix when we will be preparing the concrete mix. So we have to adjust the mixing water quantity or the quantity of water required for the mix, basically depending upon the surface moisture of the aggregate. Means if it is having the aggregate is moist, then we have to reduce the water quantity. So that way we have to adjust the quantity of water required for the concrete mix. The next step is check the calculated mix proportions by trial batches prepared and tested in accordance with the IS specifications, and make another trial if required. So we have to go for the trials based on these calculations, based on these mixes. Basically we have to prepare the trial batches, and if it is fit, okay. Otherwise, depending upon the IS specifications, we have to go for another trial. Now next method is road note number 4 method. This is also known as grading curve method. The experimental investigation is the main basis of this method. Means we have to do the lot of experimental investigation. The designed concrete must be satisfactory both in plastic as well as in the hardened state. Means in plastic state or the plastic stage, what we generally look for, the workability. So means the workability requirement should be satisfied. In hardened state, what we look for, important properties are strength and the durability. So these conditions should be properly satisfied. The choice of mix proportion is governed by both the above conditions. Means the properties in plastic stage and properties in the hardened stage. Now strength produced by different cements are not same as at same water cement ratio. Means what is the meaning of it? That if you are taking different type of cement, then the strength will depend even if you are taking the same water cement ratio. So means the strength of the concrete will depend upon the type of the cement also. The required water cement ratio to produce the design strength depends upon the properties of concrete. This method presents a set of curves relating water cement ratio and compressive strength at different ages for different type of cement. So let us see the design procedure. First of all, the average compressive strength of the mix to be designed is obtained by applying the control factors to the minimum compressive strength. Here you see in this table the relationship between minimum and the mean compressive strength. In second column, conditions are given. In third column, the minimum strength as a percentage of average strength is given. That what minimum strength as a percentage of average strength will be required or should be achieved. So first condition, if you look there in the table, that with poor control, no supervision, inaccurate volume batching of all aggregates is there, then minimum strength as percentage of average strength will be 40%. But if you go to the other conditions where you have the fair control with weigh batching, occasional supervision and use of two sizes of aggregates only, then in that case the minimum strength as percentage of average strength will be 60%. Then third case, if we look for the where we have the constant supervision, very good control with weigh batching, then in this situation the minimum strength as percentage of average strength will be 75. The water cement ratio required to give the desired necessary average compressive strength can be obtained directly from the curves given here in the figure. This figure gives you the average compressive strength and water cement ratio at different ages of the concrete. As you look on x-axis, water cement ratio is given from 0.3 to 1. On y-axis, compressive strength in kg per centimeter square is given. And you see different curves for different ages of the concrete. At different age of the concrete, you get the different curve. So first curve is 1 day, second is 3 days, for third is 7 days, then 28 days and 3 months and 1 year. So starting from 1 day to 3 year, the curves are given here. And as you see that for all curves, as water cement ratio increases, the compressive strength is decreasing. So here you can choose the water cement ratio according to the compressive strength required. Now step 3 is the proportion of combined aggregate to cement is determined for aggregates of maximum size 40 mm and 20 mm respectively. Then the fine aggregates and coarse aggregates must be combined so as to produce one of the standard grading if the aggregates available at work site differs from the standard grading. Then the proportion of cement, fine aggregate, coarse aggregate and water is determined by using knowledge of aggregate cement ratio and water cement ratio of the mix. So that way we will calculate the different proportions of the different ingredients. To produce 1 cubic meter of concrete, the quantities of ingredients required is calculated with the absolute volume method by using the specific quantities of cement and aggregate. Now let us see the method of combining the aggregates. It is desirable to proportion the available materials in such a way that the grading of combined aggregate corresponds to one of the 4 standard grading curves. Let us see analytical method. The grading of fine aggregate and coarse aggregate available at work site are here shown in the table. This table, the grading of fine and coarse aggregate available at site. You see the first column is IS sieve size. Second column gives you the percentage passing of fine aggregate and coarse aggregate. In third column, a factor is multiplied, 1.0 is multiplied to the fine aggregate. In fourth column, you see the coarse aggregate is multiplied by a factor of 3.0. Then fifth column gives you the sum of the column 3 and column 4. And the last column is the grading of combined aggregate, which is obtained by dividing the value of column 5 by 4. So that way, if you see, if the sieve size is 20 mm and percentage passing of fine aggregate and coarse aggregate is 100, then after multiplying these coefficients for fine aggregate and coarse aggregate, column 3 value is 100, column 4 value is 300 because 100 into 3 is 300. Then sum of column 3 and 4 will give you 100 plus 300 will give you the 400. And for obtaining the grading of combined aggregate, here this column 5 value will be divided by the 4 by 4. So 400 by 4, it is 100. So that way you can achieve the value or calculate the value for different sieve sizes, here as 10 mm, also for 4.75 mm by you doing this. So that way you will be getting the grading of combined aggregate. The fine aggregate and coarse aggregate of 20 mm maximum size have to be combined in order to approximate to the coarsest grading of the standard grade. Means this combination has to be done to get the or reach the approximately to the coarsest grading of the standard grade. For example, Let us assume that 30% of the total aggregate passing through 4.75 mmc, and let X and Y are the proportions of fine aggregate and coarse aggregate in combined state. Combined state means when we have mixed these fine aggregate and the coarse aggregate. Then therefore, to satisfy the percentage passing 4.75 mmc, so here we will be doing 100x upon 100 plus 70y upon 100 equal to 30x plus y upon 100. So here 100 by 100 means x only, 70 by 100 means 0.7. So that way on left hand side x plus 0.7y equal to 100 by 30 means 0.3. So 0.3 x plus y. So that way x plus 0.7y equal to 0.3 x plus 0.3 y, and finally we get the ratio of x is to y equal to 1:3. It means that the fine aggregate and coarse aggregate should be combined in a ratio of 1:3. So that way we get that what should be the percentage or what should be the ratio of the fine aggregate and the coarse aggregate. Then determination of weights of ingredients by absolute volume method. The weight of cement required to produce 1 cubic meter of concrete is found out by this method. The principle of this method is that the volume of compacted concrete is equal to the sum of absolute volume of all ingredients. Now let us see what are the limitations of this road note number 4 method. This method leads to a very high cement content, hence is becoming obsolete. This method covers only 3 shapes of aggregate and 4 types of grading, which differ greatly from practical aspects. Also, different aggregate to cement ratios are given for different levels of workability ranging from low to high, but these levels of workability are not defined in terms of slump, compaction factor or VB time, as is the case in case of other methods. Now let us see what is yield of concrete. The volume of fully compacted concrete per bag of cement is known as yield of concrete. Yield of concrete equal to twice the volume of 1 bag of cement divided by 3 plus volume of per bag of cement aggregate in loose state used for 1 bag of cement. So that way you can calculate the yield of concrete. This formula gives approximate value of the yield of concrete. Following methods may be used to obtain exact value of the yield of concrete. Means from that formula you get an approximate value, but 2 methods are there to calculate the exact value of the yield of concrete. First one is absolute volume method and second is bulk density method. Let us see first the absolute volume method. The exact yield of concrete per batch of fully compacted concrete may be calculated by the fact that the volume of concrete is equal to the sum of absolute volume of cement, fine aggregate, coarse aggregate and water. The absolute volume of loose material is the total volume of solid matter in all the particles. This is calculated from the weight and the specific gravity of surface dry material. Now, absolute volume can be expressed as weight of material divided by specific gravity into the weight of water per cubic meter. The specific gravity of cement may be assumed as 3.15. The specific gravity for aggregates normally adopted is as follows. For fine aggregate, specific gravity may be taken from 2.5 to 2.6. For quartzite, specific gravity may be taken as 2.6 to 2.7. For granite, specific gravity may be considered as 2.7 to 2.8. For basalt, specific gravity may be considered as 2.8 to 3.0, and for limestone, the specific gravity may be taken as 2.7 to 3.9. So that way, here you can take the value of specific gravity from these values for different type of this material. The specific gravity of aggregates may be assumed as 2.65 if it is not given. Now we see here another method, the bulk density method. Bulk density method is the simplest one and accurate method of calculating the yield of a batch of fully compacted concrete. The bulk density of fresh concrete is found by fully compacting the concrete into a vessel of known volume and weighing the sample. Thus, the weight of a 1 meter cubic concrete can be calculated in 6 equal layers and the surface traveled level before weighing. Then let us see what is cement factor. The weight of cement required for producing 1 cubic meter of compacted concrete is known as the cement factor. It is expressed in number of cement bags, and cement factor is the reciprocal of yield of concrete per bag of cement. So cement factor will be given as 1 upon yield of concrete. So this way we discuss method of mixed design, in which we discuss trial and error method, then American Concrete Institute method of mixed design, then road note number 4 method, and along with that we also discuss the yield of concrete and the cement factor. So you go through this video and go through the content, e-content also. So you will learn about this mixed design method, and we will continue our discussion on other topics. Thank you for watching.